Dear learners, today we will talk about the cycloid. The cycloid is not a simple circle trace. This curve was studied by Galileo, written about by Pascal and Tarlavet, solved by Newton, and for centuries many scientists have been engaged with this unique curve. Let's try to understand it together. In our educational materials, the cycloid is described as follows. That is, it is defined as the curve traced by a fixed point on the circumference of a circle as it rolls along a straight line without slipping. Indeed, that's exactly how it is. However, for more than 300 years, this has been a topic of great interest. For example, among those who study the cycloid curve are the following scientists, namely Galileo Galilei, one of our famous scientists who was born in 1564 and passed away in 1642. He is considered one of the first scientists to study the cycloid scientifically. He tried to calculate the area of the cycloid. The cycloid was regarded as the most beautiful curve. However, his calculations were incorrect. Later, Marin Mersenne. He lived from 1580 to 1648 and was the one who spread the cycloid problem among European scholars, inspiring and challenging many mathematicians to work on this problem. And after that, Blaise Pascal, who lived and worked from 1623 to 1662, in 1652 announced a major mathematical competition on the cycloid. He calculated the area and the arc length of the cycloid. He described the cycloid as the queen of geometry. Our contemporary Christian Huygens applied the cycloid in practice. He made use of the cycloid shape in pendulum clocks. One of its properties is that if a pendulum moves along a cycloid, it oscillates in the same amount of time regardless of the amplitude. This property is unique to the cycloid. This invention of the cycloid, that is, the scientific invention of the cycloid, revolutionized the determination of timekeeping mechanisms. In other words, it led to the invention of an accurate timekeeping mechanism, that is, a mechanism for precise time measurement. Here you see the contribution of technical drawing as a science to technology and scientific progress. Christian Huygens worked on the so-called Tautochron curve, that is, the Brachistochrone problem, but it was Johann Bernoulli, who lived from 1667 to 1748, who solved this problem. He proved that the exact Tautochron curve is actually a cycloid. What does this mean? For example, let me give you a simple explanation. So let's pay attention to this kind of situation. If we now, right now, release these two balls, the question is, which one will reach the bottom first? That is, this problem. It was posed to scientists by Johann Bernoulli in 1696. The answer given was that it was a straight line. But it was not a straight line. Let's look at the result. As a result, it turns out that this is actually a cycloid curve. Now, even more questions arose from this. That is, not problems, but more curiosity emerged. Why is it like this? This problem became so popular that it sparked competition and debate among scientists. Because of the cycloid, a new field called variational calculus was born. In other words, a single curve gave rise to an entirely new branch of mathematics. Later, this problem was completely solved and presented by Isaac Newton. The most interesting part is that Isaac Newton solved this problem in just one night after work. This is called the queen of geometry, or the beautiful curve that caused disputes among scientists. Interestingly, the cycloidal curve is not an ordinary geometric shape. The property of isochronism in the cycloidal pendulum was scientifically established by Christian Huygens. He called it a cycloid and demonstrated that the motion of the pendulum always occurs in equal time intervals. That is, with this kind of cycloidal curved path, even if you release one ball from the top and another from the middle, they will both reach the end at the same time. Serenatikian. This discovery increased the accuracy of clocks and also contributed to the advancement of their mechanisms. Let's draw this beautiful curve. That is, let's try drawing the queen of geometry. And regarding its solutions, mathematicians, mechanics, and through our own drafting methods, there are already various ways to draw and demonstrate it. For example, the mathematical method. Here is the mathematical method. That is, a formula is given, the formula is applied, and as a result, a curve is formed. The mechanical method as well. By placing a wheel and a point and by rotating it, the curve is traced along its path. A curve is formed. Now we draw this curve by connecting 2 points and give it a shape. You can also learn this yourself. We arrange it using the electronic board. This is only for our convenience. We arrange it accordingly. For that we use a compass from our 3 drawing tools. Take the compass and carefully mark the arc, because with the compass, as you know, the circle continues smoothly. That's why if it's too big or too small, it won't work. So at this measurement. All right, now let's color it. Okay, of course we use white for the color, but the circle's outline should be a bit lighter. And we draw it, right? All right, just like that. Now let's draw the circle. Okay, the center axes of the circle need to be drawn. Let's draw the center axis. Now the circle is ready. Now we divide it. There are different methods for dividing it. That is, you can divide it using a compass, you can divide it using a ruler, you can divide it using a protractor. So in any way. For example, you can divide it with a compass like this, without changing the radius on the compass, just without changing that radius. So by placing a point somewhere, we draw with an arc. Now we just draw a full arc, just mark it, that's all. So we do it like this and mark it. All right then, now let's carefully take the long metal ruler and the precise straight edge, and what exactly do we need to do next? First, we take the straight edge, then we find the exact center with the ruler, and now we slowly move the straight edge over to this side. Yes, okay, keeping them both together. If we need to decide exactly where to cut, we will cut along this specific side here. Using the straight edge, we cut right along this side. Now, can someone please tell me what the next step should be? How can we determine it with the ruler, for those who said 12? For instance, from our collection of rulers, we can pick the one marked with the number 30. Bring it here. And cut it at the center, making sure it goes through the center. But this particular side over here really needs to be properly straightened out, as I have just finished straightening this specific part. After taking a good look at it, now if you are going to make your precise cut, you must cut it exactly from the spot where the circle is clearly marked, and then you can simply take the entire remaining section of the material. Just draw a little, because otherwise the lines will become too many. It's best to draw from the smallest one. As I said, draw from the smallest one. Now, you align the line you just cut with the center, and if you cut the other side as well, make sure it passes through the center. Now, on this side as well, we take the spot where the circle was cut and pass it through the center. We did it this way so that we could clearly see the degree of accuracy, even though we already knew it, and that's why we divided it like this. Now let's assign different colors to each of them. Okay, or not. Let's change their colors as well. For example, let's make their color yellow. If it's yellow, then let's make the next one blue. This one, for example, let's make it the center. This one, for example, let's make it 1. And this one, let's make it 2. This one, 3. And this one, let's make it 4. That's it. 11, 12. Okay, now let's look closely at this. According to the fundamental geometric rule of the cycloid of a circle, if we imagine a specific point on the edge of a circle that moves steadily along a perfectly flat surface without any slipping at all, what exactly does the resulting trajectory of that single point give us? Well, it gives us the mathematical curve known as the cycloid, just as we previously said. In this case, we need to draw a line along the circumference of the circle. That is, it rolls along the surface. Its mathematical formula is, for example, pi multiplied by something, or let's say pi multiplied by r over 2. We can take that as the calculation. Okay, now let's look at the diameter of this, for example. Okay, what is the diameter? What is its diameter? What is the diameter of ours? Is it 2? Yes, it's 2. Okay, if the diameter is 2. First, we take our initial values and multiply them by 80, and then we perform that multiplication by 80 once again. For instance, if we take a set of specific numbers such as 3, 4, 10, and 4, and we apply this multiplication by 80 to each of them, we can see the scale increase. As a direct result of these calculations, if you multiply everything together, the total value becomes approximately 250 times 10 to the power of 2. Finally, if we take this large resulting figure and divide it accordingly, the final value that we get comes out to be exactly 12. The inside is 29. 29. Good. Now let's draw this exactly on the pipe. You do it carefully, gently, mark it with a pencil. Draw it straight, mark it with a pencil. Mark it with a pencil. So from here to this point. Now let's cut its length and see. Now we only need this part. We need to divide it. For example, you can also divide it like this, that is from 2.29. So like this, do you see? This is exactly what we get when we do the math for the circumference. It comes out to 2.29. You can also divide it from 2.29, just like that. That's all. So, of course, you can also divide it from 2.29. Now, we need to divide it using a graphical method as well. For that, let's move on. Okay, to make it easier for us, again, let's use a ruler, for example. Let's use a scaled ruler. Let's bring it to the center, just like before. Unintelligible repeated syllables. Let's mark this. For example, here is 1, here. Here is 2, here. 3, 4, 5, 6. Here is 2, 5, 5. 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 Found it, let's do this. Now here it is. It's about 251. It's about 251. Let's do ours too. It is approximately 251 in total. Okay, for the next step, let's carefully take this bright red one and place it right over here in this specific spot. Then we will aim and shoot it directly toward the large dome structure. And once it has been successfully shot, we need to make sure that we make it much smaller than it currently is. We'll take this, and it turns out we need another one. Plenty's a bit. Okay, so as we discussed, it will be a single line, nothing else. That is the whole thing. And this specific spot right here will be the mark. So we are going to draw it like this. From here, from here. There you go, respected teachers, we got it. Of course, it's appropriate to put the markers for the letter yen. Now a stroke. Draw the stroke, done, 2, 3, 4, next 2 dots here. 2 dot this one, 3 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 dot this one. Select the 3 dot option for each of these items, repeating the process for every single one shown here. 3 dot this one, 3 dot this one, shalil. We have gone through the sequence of 6, 7, 8, 9, 10, and 11 over and over again, repeating these same numbers dozens of times in a long, continuous cycle until we finally reach the end of the list. After all of that counting and repeating the same numbers so many times, okay, now what do we do? Now we need to find the center of this circle as accurately as possible right here. So we need to draw the shape once more. Then we should extend it further out. And this line here, this is the center of the area. So we need to move it right into the center. Isn't that right? First, we carefully move it over to this specific spot right here. We move it, and then we make sure to mark it exactly at this point, identifying each individual center. That is precisely why we are doing this. We take each center one by one, just like this. From the surface of the table, we take it out and set it aside. Right here, we find its center. Here is the first one, and right here is the second one, followed by the third, the fourth, the fifth, and the sixth. We continue to the seventh, the eighth, the ninth, the 10th, the 11th, and finally the 12th. By following this careful process, we have successfully found all 12 centers. Of course, let's go ahead and carefully mark all of these centers right now. So for example, we mark the centers, right? Marked narrow. 0. 1. 0. 2. 0. And the last one? 0. 12. Let's go back to the main spot. For that, we take the compass. We don't change the radius. Is that right? Careful, don't change it. But you have to be careful not to move it right here. If you learn this one step, the rest will be easy for you. Let's do the example. Okay, I brought the compass. The center. Look, I'm placing it on the new center. Pay attention to me. I placed it on the 0, 1 center. I placed it on the 0, 1 center. That's it. Now, I'm not going to draw a full circle. But if you draw a full circle with this, let's say it becomes a circle. What if I move further from the center? All right? All right, where? The color really should not be yellow. So please go ahead and change its color. The result is the line, the result is the line. This one, here, I can continue from wherever I want. I can continue from wherever I want. Continuing is this line. What about this? If I draw with one, for example, here, from this one, for example, the first class, the second class, or so on. The place where this is drawn is the point we are looking for. This is the necessary point that we need. So this point, the point, how do we find it? Let's take the point and move it around. Like this. If we do it like this, the point will be here. Let this be the exit point from the object, like this. Like this. All right, let's continue. Now, 2 centers will come here, like this. 2 will come here. Earlier, we put them together. Now, 2 have come, so what do we do next? How do we proceed from here? With these 2, how do we continue the process? Where? Now, let me draw one of them here. Let me draw one of them, and where should I draw this line? For you, we have 2 points. This is one, this point. So what exactly did we do with it after all? From the 2, the place where the 2 intersect. Now, if I don't make any assumptions, our process would stop here. So what should we do next? Should we rotate it 3 times? With 3 points, what is the accuracy of this rotation in practice? Okay. Do we have 3 points? Here. Do we have 3 points? Here we have placed them. We have 4 points. Here's our 4th. Which one? Here's the 4th. Here, 5. You too. One thing here. I will pass through here, here. Done. Done. Now you can also check here. Here are 6. It's done. I just placed it. So we have found half of the cycle. For me, I can also align it myself. Starting from the beginning, we have point number 1, then 2, 3, 4, and 5. Now moving on to the next section, what about this one right here? Let's count them out carefully. 1, 2, 3, 4, 5, and 6. If we simply continue along in this specific order, we can clearly see that the 6th point will be located right here in this spot. Where do we get that from? For example, if I say let's draw a straight line, it will be this color too. Let's keep the color. It works. For example, let's move on to the next one. Let's do it from this point here. From this point, it didn't draw a straight line. It goes back and then draws a straight line here. Here, our 6th point goes here to this here. Pay attention here. Let's move it a bit here. That's it here. Let's check the degree of accuracy. Here, this is the 6th point. Here, it's done. Now, we need to write these down and leave them here. For example, here, this one, let's write the label below, like this. 6. We don't have a 0 model here. If you look at the 60 series is this one right here. Now, this specific one is the 50 series. This one belongs to the 50 series category. This other one is also a 50 series. Let's check its 0 setting. This one over here is the 40 series, and this one is also a 40 series. That is exactly why it is standing like that. This one right here. The orange circle is arranged from our circle. Look here, this is the orange circle. From the circle, the segment coming out from the orange center, this is the orange point. That's why this is the orange side. Okay, now let's continue from where we left off. So our compass, what is our compass for? Should we use it now? Okay, let's also draw this part with the compass. Yes, let's draw this part as well. Yes, let's make this one a bit smaller. That is, let's make it a bit smaller too. Now let's do the same on the other side as well. We can find the 3rd formula from here. That's the 3rd one. Dear students, our learners here, this distance, for example, let's say it's 251, without measuring this distance directly, by measuring this distance and using the compass again, that is, by taking the same compass width twice, you can place it here, and by drawing arcs, find the point of intersection. That's how it's done. Now we need a compass. Our compass. All right, our compass. Now the radius. This radius can be changed, or let's just keep the radius as it is. One radius. Needs to be found. All right, now then. We have come to the 7th circle, that is to the center of the circle. We've reached the center of the 7th circle. We've reached the center of the 7th circle. Now we need to come from the 7th point. Is there anything we should pay special attention to here? All right, should we place it at the center of the seventh circle or not? Will the lines overlap too much, or will these lines get mixed up? Let's make the lines a bit less dense. All right, the color. This color doesn't look good. Here, this is the line I drew. Here, this is the line from the seventh point. It would truly be a very beneficial and highly advantageous decision for all of us involved if we could somehow find a way to effectively cut this specific part off and remove it entirely from the final version of the project we are currently working on together. Taking this action would likely improve the overall quality and flow of the work significantly, ensuring that the end result is as polished and professional as it can possibly be for our audience to eventually see and appreciate. Let's bring it here. Let's call this our machine. Here, let's set the meeting time for 7 o'clock at the mosque. Let's do it exactly like this. Try repeating it once or twice. We're not going far. We're going to 8. 8. At 8, it's a bit lower. It comes out from here. Let's draw it a little lower and leave it because, well, our 8th point will come here. So draw it here and leave it. You'll see for yourself. Now, well, let it stay a bit. Let's leave it here and draw it. You'll see for yourself. So from the 8th point, let's make the cut here. We're making the cut from the 8th point, just a bit lower. Now from the second one, you can use a ruler, or if you have a measuring tape, that's fine too. It will come out the same. Okay, this is the 8th point. All right, let's do the 9th. After the 8th comes the 9th. This is our 9th point. Yes, that's right. If this is the 9th point, the 9th point will be here, right? The 9th point will be here. 10. Where do we put the point? All right, now the point is done. It will be here. That is, it will be in this place. It's worth $10. $10 worth. Let's do it now. All right. The sequence has been restored. With 2, it makes $3 or $3.50. We hung it up. Done. So I said we need to reach up to these 2 points. Up to the points, just say that. Okay, now we have 10. Now we go to 11. Our 11th one will be right here. Here it is right here. What do I want to say here? This together with 1 will look nice. Yes, right? This is the package. That's it. That's it. Oh, are you squeezing it like that? Did you just pull it tight? And then that's how it goes. Then here, the last one. Now, let's go ahead and draw the very last thick line, or right here. Through the 10 payment system, we do it like this, AN. This is how we take it in this form. I think more broadly there are dozens here, for example, pop in Malavida, like this. 7. 0. Yes, this one. 8. Back in the era of the Soviet Union, you have to understand, my brother, that there were exactly 10 of them in total during that whole period of history. And it really was a completely different world back then. I will take the original here. So, looking at the SSV options we have here, is this particular one the specific model that you were actually referring to for our project? When we look closely at this curve, that is to say, when we follow the path along this specific curve right here, we need to do it with the help of a ruler. We need to spend it. Unfortunately, there is no ruler on this board. There is no ruler. If both are missing, then in this case, now let's support it. Let's try to create a device by reducing the size. Shavkat, let's see. 45. Oh. Let's see how many we've passed. Let's look at this problem. Okay, let's draw it in red. These are temporary for now. The food. You know, a ruler is usually used, but let's try it by hand now. Oh. Now, all right, everyone, let's try to compete, brother. Akmal, why don't we go ahead and try to take a look at enlarging it in this case? As is known, and the problem. Xian is capable of it. You have to draw without being afraid of making mistakes. You need to learn. Now, as for me personally,
The supply-side platform, commonly known as SSP, is a specialized software system used by digital publishers to manage their advertising spend and maximize revenue from various ads.
The flowers of the gardens, the eternal flowers in your gardens. Ask about them, Ukar.
whatever it is, Japanese. Now the elders, how do I draw it? What's the next step?
That is exactly 1 centimeter.
Actually, let's not all make it a rule.
6 centimeters of soil represent the vast wealth of our entire country. I am the proud little owner of this land.